Hello students, I am Dr. Priyanka Thakral. Today, I bring you a learning episode in BSc Forensic Sciences on behalf of the content writers Dr. Vimal Rar and myself on an important unit of paper Forensic Chemistry, that is distillation, in which we will discuss about the various important methods and procedures used on daily basis in forensic science laboratories. These techniques have a wide variety of applications in forensic sciences. Let us start our episode with a look at what we are going to learn today. Modules. So, we will start with Introduction and History of Distillation. Following this, we will move to Principles and Procedures of Distillation, where we will talk about distillation process, principle, procedure, and then we will move to types of distillation techniques, advantages and disadvantages of distillation, application of distillation methods, and finally forensic applications of distillation techniques, and finally conclusions. Distillation is a widely used technique for purification of liquids and separation of mixture of liquids into their individual constituents. The word distillation has been derived from the word distill, which originates from the Latin verb distillare, which means to drip down. The word distill, as per English vocabulary, means to reduce it, but keep the most relevant part of it. And in chemical conventions, which is of importance to us, it refers to the heating of a liquid until it changes to vapor form and then making it liquid again by condensing or cooling. So, we can say that distillation is a process which involves heating of a liquid mixture solution, deriving of the vapor, and then collecting and condensing this vapor to obtain the more volatile component of the mixture separately. Or one can even define distillation as a procedure in which a mixture of two or more components is separated into its constituent fractions of desired purity by the application and removal of heat to and from the system. So, some familiar examples of distillation includes the distillation of fermentation products into alcoholic spirits like vodka and gin, and crude oil fractionation into useful products such as gasoline, heating oil, etc. The distillation procedure separates two or more liquid constituents in a given mixture solution based on the principle of relative volatility or boiling points. So, for sake of clarity, let us now know how volatility and boiling point are defined. Volatility refers to the inclination of a substance to evaporate at normal temperatures, and boiling point is the temperature at which the liquid boils and turns into vapor. So, the greater the difference in relative volatility or boiling points of the mixture components, the higher is the non-linearity and the easier it becomes to separate the components of a mixture using distillation process. So, the distillation procedure takes into account the production of vapor by boiling the liquid mixture and then removal of that vapor by condensation. Due to relative differences in volatility or boiling points, the vapors of the sample mixture will always be richer in the component constituents that have lower boiling points, and liquid will always be richer in the high boiling point component constituents. So, when these vapors cool down and condense, the condensate contains more of the volatile components. At the same time, the liquid sample left contains more of the less volatile components. So, in brief, distillation is a process of many steps, yet it is simple to treat and conduct. It comprises of heating the liquid sample to its boiling point, where the vapors will form, and then these vapors are transferred into the different part of the apparatus, where condensing of vapors takes place and then it is collected into a container. From chemistry point of view, distillation is used to purify the liquid compounds. There are various factors which affects a successful distillation. For example, the differences between boiling points of the liquid compound, differences between their vapor pressures, any human error and the type of errors associated with instruments and apparatus. Although almost everyone has a fairly good idea about what distillation means, but the important aspects that seem to be missed from the manufacturing point of view are: number 1, distillation is a widely used separation technique. Number 2, it consumes large amount of energy, that is in terms of cooling and heating requirements of the mixture. And thirdly, it contributes to more than 50% of distillation plant operational costs. The best approach to reduce operational costs is by improvising the efficiency and operation of the process via optimization and control. To achieve this improvisation, in-depth understanding of distillation principles, procedures and design is very much essential. So, with this introduction, now let us move to the history of distillation. The discovery of distillation is generally attributed to Greeks, as they used spirit distillation for distilling intoxicating and flammable liquids and also for wine distillation. Boiled was the term given by Greeks for distillation, and they used salt for distilling many recipes. Scholars reported the earliest recipe of distillation of wine. The basic principle of distillation is that different compounds or components turn into vapor form at their particular temperature. This fact was known to the Greeks. That's why they used distillation for purifying seawater. They also had knowledge about the process of capturing the elusive substance like alcohol from wine. The Greeks heated the wine in a vessel very slowly, and the small mouth of the vessel was covered with a bowl. The alcohol would collect as condensed vapor inside the bowl. The addition of a downward slanted tube to the apparatus aided the cooling and condensation and its collection in a receiving vessel. Therefore, the word distill comes from the Latin verb distillare, which we now know means to drip down. From 2nd century BC in Alexandria, Egypt, various philosopher chemists practiced the process of distillation. By the 1st century, these chemists employed 3 to 4 various styles. Maria invented one of them, which included 3 bronze outlets. The goal of distillation for them was to extract mercury, arsenic and sulfur to change the external composition of base metals and to color them gold. According to them, this distillation is a ritual practice, that is, release and healing from all the pain from the soul. During the 6th century, Persians started practicing distillation in their medical schools to make herbal tinctures. During 9th and 10th centuries, the Arabs used distillation for producing rose water and other herbal materials, and they created solvents for base metals. In 14th century, European countries allowed the houses and churches to make aqua vitae, which in Latin means water of life. This is in reference to a concentrated aqueous solution of ethanol, or typically prepared by distilling wine. In general, this is a generic name for all types of distillates. In 17th century, commercial distillation was started by the industries. And so, we now have distillation at industrial level. Distillation process. Let us try and understand the process of distillation at ground level. So, what we want is the understanding of what happens upon heating a liquid. Over here, we are using the term heat and automatically what comes to our mind is temperature. One must remember that temperature is a measure of average kinetic energy of the constituent particles present in the system. Temperature is an intensive property, whereas heat is taken as the measure of overall energy content of the system. Heat is also referred to as a process quantity because it is defined in context of a process. That is, it is a path function by which actually energy can be transferred. Heat is an extensive property. Let us suppose at some temperature value, some liquid molecules have sufficient kinetic energy to escape into the vapor phase. That is, they evaporate. And some of the molecules in the vapor phase return to the liquid state, that is, they condense. An equilibrium sets up with molecules of components moving back and forth between the liquid phase and the vapor phase. At high temperature values, more molecules have sufficient kinetic energy to move into the vapor phase, and so the number of molecules present in the vapor phase increase on temperature elevation. If the liquid sample is present in a closed container with an attached pressure gauge, degree of vaporization can be obtained quantitatively. This pressure is referred to as vapor pressure of the component, and this can be measured at different temperature values. Now, with this understanding of distillation process, let us now move to the principle of distillation technique. First of all, one needs to understand that distillation is a physical process and not a chemical process. Distillation is based on a very simple idea that the vapor formed after boiling a mixture will be abundant in terms of components that have low boiling points. Thus, it can be concluded that condensate component or compound will have more volatile constituents. When the equilibrium is attained between liquid and vapor, then any pure liquid will have a constant boiling point. The process of distillation involves heating a sample of a liquid to convert it into vapor, which is then allowed to flow in another location where it is cooled, condensing it back into a liquid form. During distillation process of a liquid compound, the temperature of the flask will increase throughout this process. Let us assume the liquid mixture contains two different liquids A and B, and their boiling points are designated as TA and TB, and their vapor pressure is also different. So, you can see the vapor liquid phase diagram on your screen. This figure represents the composition of vapor with a mixture of liquids. Here, X1 defines composition of a liquid A and B both in 50% proportion, having T1 as the boiling point. By following the line of T1 horizontally, the composition of vapor which is in equilibrium with X1 at temperature T1 can be determined. Again, if we look at this figure, the composition of X2, which is 80% of A and 20% of B. If you observe this carefully, the vapor is particularly enhanced in component A, which is more volatile because TA is less than TB. To determine the composition of X2, the vapor will condense and temperature will be lowered from T1 to T2. When X2 is permitted to reach temperature T2, then they both will be at equilibrium with vapor of X3 composition, which is 90% of A and 10% of B. And the last step is to condense and re-vaporize the vapors of X3 composition to obtain pure A liquid. This process, so explained in the phase diagram, follows Raoult's law, which states that when two liquid samples are completely soluble into each other, then the total vapor pressure is the sum of the two partial vapor pressures. Miscible sets of liquids are referred to be ideal only if the involvement of every component to the total vapor pressure is directly proportional to its mole fraction. So, total vapor pressure becomes Pa plus Pb, where Pa is equals to mole fraction of A into Pa naught and Pb equals to mole fraction of B into Pb naught. So, P total then becomes mole fraction of A into Pa naught plus mole fraction of B into Pb naught, where Pa and Pb again are the vapor pressures of liquid A and B. Pa naught and Pb naught are the vapor pressures of pure liquid A and B if they alone occupy the same volume. And with this, we can correlate the phase diagram. Now, let us consider the example of heating cyclohexane to understand this distillation process. On heating cyclohexane, which is a liquid hydrocarbon, and its vapor pressure is measured at different temperatures, as can be seen in the graph shown on your screen. As you can see, with increase in temperature of cyclohexane, the corresponding vapor pressure value increases, and this is generally true for all liquids. At some temperature value, the liquid begins to boil. This boiling occurs when vapor pressure of the liquid becomes equal to that of the applied pressure. In open atmosphere, the applied pressure is equal to the atmospheric pressure, which is 1 atmosphere. For cyclohexane, as can be seen from the graph, this happens at 81 degrees Celsius, and therefore, boiling point of cyclohexane equals 81 degrees Celsius. The boiling point of a liquid in an open container can then be defined as the temperature at which its vapor pressure becomes equal to that of the atmospheric pressure. It is important to note that in vacuum, the liquid's boiling point is lower than the liquid's boiling point at atmospheric pressure. This can be exemplified by looking at the boiling point of water at different pressures. We know that the atmospheric pressure decreases with increase in altitude. So, the boiling point of water has the value of about 95 degrees Celsius in Denver, which is about 5200 meters above sea level. And above 10,000 meters, the boiling point of water becomes 90 degrees Celsius. Since the liquids boil at low temperature values under vacuum, vacuum distillation technique can be applied to distill high boiling liquids that would decompose otherwise at their normal boiling points. So, as you can see on your screen, another graph where we have plot of vapor pressure versus temperature. From here we can conclude that for toluene, the vapor pressure equals atmospheric pressure at 111 degrees Celsius temperature. So, the boiling point of toluene is 111 degrees Celsius. Now, if we compare the vapor pressures of toluene and cyclohexane at any temperature value, the vapor pressure of cyclohexane is greater than the vapor pressure of toluene. So, it is important to note that the vapor pressure of the lower boiling point component is greater than the vapor pressure of the higher boiling point component at any given temperature. Thus, the vapor above liquid will always be rich in the lower boiling point component compared to the relative amounts in their liquid medium. With this, we now move to the procedure of distillation method. As you can see on your screen, a typical distillation apparatus setup where the apparatus contains the following components: distillation flask, where the separation of the liquid mixture is done in flask; condenser, the function of condenser is to condense and cool down the vapor; and the receiving flask, where one can collect the pure liquid coming out of condenser. The liquid mixture to be distilled is placed in the distillation flask and then heated. According to the principle, the liquid having low boiling point will vaporize first in the list, and the liquid with high boiling point will remain in the distillation flask and will be taken as residue. When the vapor is formed, the next step is vapor passing to the condenser, where all the cooling of vapors takes place. And finally, the vapor is converted back into the liquid, which is then collected in the receiving flask. So, we have different types of distillation techniques which we can use in forensic sciences, starting with steam distillation. Steam volatile substances can be separated or isolated from blood, urine and other test samples. Steam is passed into the sample and the aqueous distillate is collected by condensation. The other method is fractional distillation. This is a type of distillation which enables separation of a mixture of volatile liquid differing marginally in boiling points. The other technique is vacuum distillation. In this type of distillation method, the pressure of the mixture of liquid to be distilled is lessened than the vapor pressure of the mixture of liquid, which results in evaporation of volatile liquid. The principle behind working of vacuum distillation is that boiling happens only when vapor pressure of liquids surpasses the normal pressure. And finally, the last method is sweep co-distillation. This is a specific type of distillation approach based on the preferential boiling of components in a mixture, especially for pesticides from oil, lipids or plant extracts by using inert gas stream and subsequent isolation of volatiles on cold traps or solid adsorbent takes place. Starting with advantages of distillation method. These methods are less expensive methods for separating mixtures of liquid components. This method can also be reused. This technique is quite efficient in nature and high quality end products are expected. It has wide range of applications. With this, now let us move to the disadvantages of distillation method. If the compound to be distillated is solid in nature, then it should be first converted into liquid compound. Next, azeotropes. Azeotropes, it is a mixture of liquid. When this mixture is vaporized, the vapor produced have some composition as of liquid mixture. So, in this case, simple distillation techniques can be of no use. Thirdly, difficulty in separation of unwanted materials like herbicides and normal water. They both have similar boiling points, that is 100 degrees Celsius. Thus, separation of these two are tough because of high levels of acidity. On larger scale, distillation requires a very large amount of energy. The applications of distillation can be classified into 4 categories. Number 1, laboratory scale. Number 2, industrial distillation. Number 3, distillation of herbs, medicinals or perfumery. And 4th, food processing. Now, the last 2 methods are discretely different from the first 2 in the sense that in the distillation of herbs and food beverages, the distillation is more to transfer all required volatile components from the source material to the distillate. That is, over here the ultimate goal is to extract all useful or required volatile components from the source material. In forensic sciences, it is used for acidic distillation of volatile liquids like ethanol, methanol, phenol, halogenated hydrocarbons and cyanides. It is used for basic distillation of drugs like aniline, pyridine, nicotine, etc. It is also used in fractionation of petroleum hydrocarbons. A mixture of kerosene oil or mineral turpentine oil in an oil-water emulsion may be separated using this method. Distillation is a widely used technique for purification of liquids and separation of mixtures of liquids into their individual components. The word distillation has been derived from the word distill, which originates from the Latin verb distillare, which means to drip down. Distill, as per English vocabulary, means to reduce it but keep the most relevant part of it. In chemical conventions, it refers to heating of a liquid until it changes to vapor form and then making it liquid again by cooling. One can define distillation as a procedure in which a mixture of 2 or more components is separated into its constituent fractions of desired purity by the application and removal of heat to and from the system. Various modifications of the basic distillation process are used for specific purposes such as steam distillation, fractional distillation, distillation under reduced pressure, sweep co-distillation, etc. And the applications of distillation has been classified into 4 categories, which include laboratory scale, industrial distillation, distillation of herbs or perfumery and medicinals, and food processing. These methods have great utility in forensic sciences. Now, this is time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in for assignments, MCQs, quizzes and LORs and other materials. Till then, keep studying. Goodbye.